This video deals with the techniques for solving simultaneous equations. By simultaneous equations, it means equations being satisfied at the same time. But this all makes sense soon. For the purpose of your WAEC exam for simultaneous equation, you're only going to have to deal with two equations in two variables. So for instance, here we have an equation and we have another equation. So we have two equations. And then there are two variables. There's the variable y and the variable x. The same variable y and same variable x. So there are only two unique variables. X is one of the variables and y. These are the equations you're going to deal with. And we're going to have to solve these equations. If you recall before, we were only dealing with equations in one variable. So an equation like x plus 1 equals 3. And the solution for this was simply x equals 2. Because when x is 2, this equation is satisfied. Now, we need to know a value of x and a value of y, which when we substitute into this equation is satisfied, and which one we substitute into the equation gives a situation where this equation is satisfied. So we need a value of x and a corresponding value of y, which causes equation 1 and 2 to be satisfied. Unlike this case where we just needed a value of one variable x just to satisfy one equation, now we need the values of two variables which satisfies two equations. And that's what we're going into. This video deals with one of the techniques for solving simultaneous equations, where we have two variables and two equations. So solving two equations in two variables. There are actually two methods. The first one is the method of substitution. The second one is the method of elimination. And this video just deals with method of substitution. So I'm going to break down the whole method into a series of steps. And here's the first step. But before looking at that, this is the system of two equations. We have two equations in two variables. You have this equation x plus y equals 40, which has the variables x and y, and another equation, so I'm going to call this equation 1, and another equation 4x minus 2y equals 10, which has the variables x and y. So two equations in two variables. We're going to apply the method of substitution. Well, the first step says choose one equation and one variable. Just choose one equation and one variable. So say I choose equation 1 and I choose the variable x. I've kind of complied with the step so far. It now says the other variable, so y, is the rejected variable, and the other equation is the rejected equation. So you see where this comes from. We've chosen an equation and we've chosen a variable. So just in order to have a name for the other equation and the other variable, we just call them the rejected ones, the ones we didn't choose. So equation 2 is the rejected equation and variable y is the rejected variable, and it's just a name I've given. You probably won't find this method used in any book. Now the next step says make the chosen variable, in our case x, the subject of the chosen equation. Our chosen equation is equation 1. So we want to make x the subject of this equation. We want to isolate x on the left hand side so that x will be the only term that appears on the left hand side and x only appears on the left hand side. Now we have an annoying y on the left hand side, so let's get rid of it. We have a plus y. So we get rid of this by subtracting y from the left hand side, and we have to do the same thing to the right hand side of this equation. This gives, simplifying gives, so I'm assuming by now that you're comfortable with changing subject to formula because we've done so many examples on it. So now we have x equals 40 minus y. X is the subject now of this equation. So we've complied with step 1, we've complied with step 2. It's easy so far. Now to step 3, which says substitute the result obtained in the last step into the rejected equation and simplify. So we're going to substitute the result obtained in the last step. The result obtained in the last step says that x is equal to 40 minus y. And what this means is x is essentially 40 minus y. X can be replaced with 40 minus y. So we're asked to substitute this result into the rejected equation. Recall the rejected equation is this: 4x minus 2y equals to 10. The equation we didn't choose, equation 2. 4x minus 2y equals 10 is the rejected equation. Now we need to substitute the result obtained in the last step into this equation, and this is the essence of the method of substitution. Substituting this result into this equation. Wherever we see x, we replace it with 40 minus y, and that's what we're going to do here. Instead of x, 40 minus y minus 2y equals to 10. And now what we've done is If you look, the equations were given, there are two different variables, x and y. Now, even at this point, we had an equation with two variables. But all of a sudden now, we have an equation in just one variable, the variable y. And you solved equations involving just one variable, and they've been easy. It's just been a case of changing the subject of the formula. So now we're just going to proceed. So we substitute the result obtained in the last step into a rejected equation. Now we just have to simplify. Simplify this equation gives 160, 4 times 40 minus y is 160 minus 4y, because 4 times 40 is 160, minus 4 times y, 4y, minus 2y equals 10. This gives 160 minus 6y equals 10. And now we've simplified the equation. I'm going to call this equation 3 because we got this equation from step 3. Now to step 4. Make this rejected variable the subject of the equation obtained in the last step and note down its value. So we're just going to make y the subject of this equation. We're going to make the rejected variable y, which is y, the subject of the equation obtained in the last step, equation 3. Y is going to be made the subject. Simply means we need to isolate y on the right hand side. So let's get rid of this 160 from the left hand side. Let's subtract 160 from both sides. Doing so gives 160 minus 6y minus 160 equals 10 minus 160. We're arranging this equation as this is valid. All that's been done is just swap in these two positions. 10 minus 160 is minus 150. This gives minus 6y equals minus 150. We just want y on this left hand side, so let's divide through by the coefficient of y, which is minus 6. Dividing through by minus 6 gives minus 6, and minus 6 is 1, so we have y equals, what's this? Minus cancels minus, so don't confuse that as a plus. I don't know how to, well, let's do it this way. Minus cancels minus. Well, 6 here 1, 6 here 2, 5. So y is 25. So this step just wanted us to make the rejected variable the subject of the last equation, the equation obtained in the last step, and we've achieved that now. We now know that y is 25. So now we have a value for y, because if you recall, solving these two equations is just a case of determining values for the variables that satisfy both equations. Now we have a value for one of the variables, so we just need to now determine the value of the other variable, which is x. This brings us to the next step, step 5, which is the final step. Substitute the obtained result, which is y equals 25, into the chosen equation and determine the value of the chosen variable. So now we know what y is, we want to know what x is. And this final step says substitute this result into the chosen equation. And recall, the chosen equation is x plus y equals 40. So this is the chosen equation. So again, we are substituting, and this is the method of substitution. It involves substitution. We're substituting y equals 25 into this equation. We're replacing y with 25. Anywhere we see y, we put 25. So y has been replaced with 25. And now we need to determine what x is. We need to solve this equation. We just need to make x the subject of formula. This can be achieved by just subtracting 25 from both sides. And doing so gives x equals 15. So now we know x is 15, and previously we determined that y was 25. So our final result is x equals 15 and y equals 25. And these are the solutions to the given equations. X plus y equals 40 and 4x minus 2y equals 10. So now let's just go back to the underlying concept behind solving equations. For the equation x plus 1 equals 3, the solution to this equation is a value for the variable that causes the equation to be satisfied, i.e. causes the left hand side to be equal to the right hand side. For this equation, the solution is x equals 2, because when x is 2, the left hand side is 2 plus 1, which is 3, and the right hand side is also 3. In this case, we have two equations and two variables, and we've determined that when x is 15 and y is 25, both of these equations are satisfied. So let's test it. In the first equation, the left hand side, which is x plus y, is 15 plus 25, which is 40. The right hand side is 40. So when x is 15 and y is 25, the first equation is satisfied. Let's see if the second equation is satisfied. When x is 15 and y is 25, let's see what the second equation becomes. Second equation is 4 times x, so 4 times 15, minus 2 times y, 2 times 25. That's the left hand side of the second equation. This gives, what's 4 times 15? That's 60. 2 times 5, 2 times 25 is 50. So left hand side of value of 10. The right hand side value, as you can see, is 10. So when x is 15 and y is 25, the left hand side value, which is this, is also equal to the right side value. So when x is 15 and y is 25, both of these equations are satisfied. I want you to try substituting random values of x and y, so you can see that not just any two values will satisfy these two equations. Try x equals 1 and y equals 2 and see if equation 1 is satisfied and if equation 2 is satisfied. You find that the equations will not be satisfied. It's important to use this method of substitution to determine valid values of x and y, of the variables in the equations. So here's an example of a system of two equations in two variables. The variables p and q, and we have an equation 1 and equation 2. So we're going to solve using the method of substitution. Method of substitution. So I've left the steps in these rectangular boxes. The first step says choose an equation and a variable. So I'm going to choose equation 1. I'm going to choose variable q. The other variable is a rejected variable, so p is the rejected variable and equation 2 is the rejected equation. So I've chosen variable q and equation 1. That's the first step, complete. The next step, step 2, says make the chosen variable q the subject of the chosen equation 1. So make q the subject of equation 1. What's equation 1? 2p plus q equals 25. So we're going to make q the subject of the formula. Select q on the left hand side. How do I do this? Well, I have a 2p on the left hand side and I just want q. Let's get rid of the 2p. This can be done by subtracting 2p from both sides. So 2p plus q. The left hand side becomes 2p plus q minus 2p. Right hand side becomes 25 minus 2p. The same thing is done to the left hand side as is done to the right hand side. Rearrange this equation as to be give this. So all that's been done is a swap in position between q and minus 2p. Simplifying this gives 2p minus 2p is 0, so we just have q equals 25 minus 2p. So now the chosen variable q is now the subject of the formula. Fine, step 2 is complete. The next step, which is step 3, says substitute the result obtained in the last step into the rejected equation and simplify. So the result obtained in the last step is this. Q is equal to 25 minus 2p. So we know that q is actually this term, 25 minus 2p. And I'm going to now substitute this result into the rejected equation, which is equation 2, which is 6q minus p equals 46. 6q minus p equals 46 is the rejected equation, and I'm required to substitute this result obtained in step 2 into this equation. This is achieved by replacing q with 25 minus 2p. So 6 times q, which is 6q, is now 6 times 25 minus 2p. We now have the minus, we have our p equals 46. So now I'm going to simplify. 6 times 25 is 150. Minus 6 times 2p is 12p. Minus p equals 46. So this is 150 minus 13p equals 46. So step 3 is complete. So I'm going to call the equation obtained in step 3 equation 3. The next step says make the rejected variable the subject of the equation obtained in the last step and note down its value. So we're going to make the rejected variable, which is p. Remember, q was a chosen variable. P, the rejected variable, is going to be made the subject of the formula in the equation in the last step. P is going to be made the subject of the formula in equation 3. And this is easy to achieve because we just have to isolate p on the left hand side. On the left hand side currently we have 150 minus 13p. I just want p. So a good first step is to get rid of the 150, and this can be achieved by subtracting 150 from both sides. So this can be done like this. Subtracting 150 from both sides gives this. Rearranging to put 150 and minus 150 together gives a left hand side of this, and the right hand side remains this. 150 minus 150 is 0, so this cancels out. We're left with minus 13p equals 46 minus 150, and that's minus 104. We want to isolate p on the left hand side because we want p, the rejected variable, as a subject of the formula. This can be achieved by dividing through by minus 13, which is the coefficient of p here. Doing so, we get minus cancels minus, 13 and 13 is 1. So we have p equals, minus cancels minus, so we have p equals 104 over 13. P is equal to 8. So now we've noted down the value of the rejected variable. So now we know what p is. We now need to know what q is. Well, to find q, we go to the last step, step 5, which says substitute the obtained result, which is p equals 8, into the chosen equation and determine the value of the chosen variable. So p equals 8 we substitute into the chosen equation, which is equation 1, which is 2p plus q equals 25. Substituting 8 into this chosen equation gives, instead of put 8, we replace p with 8 basically. And we just have this 2 times 8, 16, plus q equals 25. So we can easily determine what q is by making q the subject of this formula. Subtracting 16 from both sides gets rid of the 16 as follows. Simple rearrangement gives, so we're just swapping the position of q plus q and minus 16. So simplifying, 16 minus 16 is 0. We just have plus q, which is the same thing as q. 25 minus 16 is 9. So now we know that q is 9, and we already determined that p is 8. So the solution is as follows: p equals 8 and q equals 9. And these are the solutions of the given equations, equation 1 and 2. So what I want you to do is substitute p equals 8 and q equals 9 into equation 1. Check that it's satisfied. Substitute p equals 8 and q equals 9 into equation 2 and check that the equation is satisfied. You'll find that in fact it is. And then I want you to substitute random values, so p equals 2 and q equals 1, into both equations and see what happens, just to make sure you understand why determining specific values for the variables is important. Here's another example of two equations in two unknowns. As you can see, we have two equations clearly. What are the two unknowns? We have one unknown variable or unknown is x. The other one is y. Even though y doesn't appear here, we're looking at the two equations as a system. There's x present in this system of equations and there's y present. So we have two variables and we have two equations. So what's the first step? First step, choose one equation and choose one variable. So I'm just going to choose equation 2. I'm going to choose the variable x. Well, that's the only variable in equation 2 anyway. So I've chosen x and I've chosen equation 2. Okay, and just circle that. So next step, I'm going to make x the subject of the formula in the chosen equation. So in 2x equals 4, x is simply made subject of the formula by dividing through by 2. And that gives x equals 4 over 2, which is x equals 2. So dividing through by 2, so x equals 2. I've isolated x on the left hand side. X is subject of the formula. Fine. Now I'm going to substitute the result I just obtained, x equals 2, into the rejected equation. The rejected equation is equation 1, which is 3x plus 7y equals 41. 3x plus 7y equals to 41. And let's substitute x equals 2. Replace x with 2 in this equation. This is equation 1, the rejected equation in 1. Doing so gives 3 times x, which is 3 times 2, plus 7y equals 41. Simplifying gives 6 plus 7y equals 41. So that's step 3. And I'm going to call this equation 3. Now we're going to move to step 4. It says make the rejected variable the subject of the equation obtained in the last step. So the rejected variable is y. I'm going to make it the subject of equation 3. So we have 6 plus 7y equals 41. So I'm going to make y the subject of the formula. So I'm just going to make y the subject of 3, equation 3. Now just note that by making y the subject of the formula, we're determining the value of y. And if you just slow down and go back to the beginning, what's our objective? Our objective is to determine a value for x and a value for y, which causes these equations to be satisfied. We've got to the stage where we're now making y the subject of the formula. We're now determining a value for y. So starting from equation 3, we need to isolate y. So let's get rid of 6. Subtracting 6 from both sides gives 7y equals 41 minus 6. 7y equals 35. Dividing through by 7 gives y equals 35 divided by 7 is 5. So now we know y is 5. We have one value of one of the variables. We now want to know what x is. By substituting this y equals 5 into the chosen equation, which is equation 2. So if you look at the chosen equation, that's equation 2x equals 4. We're going to replace y with 5. Y doesn't appear here, so we just proceed. 2x equals 4. Making x the subject of the formula gives x equals 2, which we already did. If you recall, we already determined that x was equals 2, even if some of you might not have noticed. We determined that x is 2. But just in terms of following the steps, you just have to carry out this last step by trying to replace y with 5 in the chosen equation. But then we realize that y didn't appear, so we just continue and we get x equals 2. So we have x is 2 and y is 5 as a solution. And you can try replacing x with 2 and y with 5, and you see that both equations are satisfied. So here's a final example. 2 equations in 2 variables. First step, choose an equation and choose a variable. So I'm choosing equation 1. I'm choosing the variable x. So I'm choosing x and equation 1. Next step, make the chosen variable the subject in this equation. I'm going to make x the subject in equation 1. So equation 1 is x plus y equals 2. So I'm writing out equation 1. I'm going to make x the subject, subtracting y from both sides. If I get rid of the y, x is the only term on the left hand side, and it will be the subject of the equation. So this gives x equals 2 minus y. So now I move on to step 3, which says substitute the result obtained in the previous step into the rejected equation. So x is equal to 2 minus y. I'm going to replace x with 2 minus y in the rejected equation, which is 7x minus 2y equals minus 4. So rejected equation, 7x minus 2y equals minus 4. Wherever I see x, I replace it with 2 minus y. So 7 times x, instead of x, 2 minus y, minus 2y equals minus 4. Simplifying gives 14 minus 7y minus 2y equals minus 4. All I did was just expand this. 7 times 2, 14, minus, 7 times y, 7y, minus, 2y, 2y, and so on. Simplifying this gives 14 minus 9y equals minus 4. So now the next step says make the rejected variable the subject of the equation obtained. So I'm going to call this equation 3 because we obtained this equation in the, well, it's the third equation I'm labeling because I've labeled equation 1 and 2. So this equation obtained in step 3, I'm going to call it equation 3. I need to make the rejected variable, which is y, the subject of the formula. So I'm going to do that here. I'm just going to rewrite it. 14 minus 9y equals minus 4. Making y the subject of the formula, isolating y on the left hand side. So I'm going to actually do 2 different approaches. Here, I'm just going to get rid of the 14 by subtracting 14 from both sides. This gives me minus 9y minus 4 minus 14, which gives minus 9y equals minus 18. I'm going to divide through by minus 9, which gives me y equals minus 18 over minus 9. Minus 9 here, 1, 9 here, 2. This gives me y equals 2. That's one approach to get y equals 2. Another approach is as follows. I do the same thing, subtract 14 from both sides because I'm trying to isolate y. And that gives me minus 9y equals minus 4 minus 14, which gives minus 9y equals minus 18. Now I'm going to multiply through by minus 1. I want to get rid of the minus sign. That's another approach because no one really likes minus signs. It's easier to work with positive signs than minus signs in general in maths. So you can multiply through by minus 1. So minus 1 times minus 9y equals minus 1 times minus 18. Doing so gives 9y equals 18. And now I can just make y the subject by dividing through by 9. So there's so many ways to get to the desired solution, but the key thing here is that y is equal to 2. So the next step says substitute the result obtained. So the result obtained is that y is 2. Substitute this result into the chosen equation. Chosen equation, equation 1. X plus y equals 2. So this is our chosen equation, x plus y equals 2. and I'm going to substitute this result there. So now we know the value of one variable, y equals 2. Let's find what x is, and that's achieved by replacing y with 2 here. Gives x plus 2 equals 2. X is equal to 2 minus 2 because I'm subtracting 2 from both sides. 0, x equals 0. So x is 0 and y is 2. And this is the last example. So just summarizing the steps. You have two equations with two variables. Choose one equation, choose one variable. Make the chosen variable the subject of the formula in the chosen equation. Substitute this result into the rejected equation to obtain an equation. I call this equation equation 3. Make the rejected variable the subject of the formula. So we have here. So now and by making that the subject of the formula, you have its value. And then to find the other variable's value, substitute this result into the chosen equation. And that gives x equals 0. So we now have the two results. So that's all it is.